Okay, good. So this is chapter number 8. Okay. We are going to start talking about operator overloading. Operator overloading is something not very complicated. The idea is very simple. The idea is this. Let me start a new whatever. Let's say I have this rational class. Remember our rational.h. I included it. Whatever other includes, I don't know what they are. Okay. In our main function, okay, I have a rational class objects, two of them. One of them is 3/4. The other one is R2. It is default R3 and R4. Okay. Well, usually I used to say things like R2 gets the value of, I guess the default values of these are 1/1. Okay. I would say add R3. Okay, maybe R3 should have something 1/2. Okay. So I used to say this is nice, but if I like to add more than one thing, what I am going to do? I need to put another add here, right? Okay, because this one is going to return a rational, and I would add another one. Let's say I'm going to add 3 R4, which is 1/1. Okay, so it is okay, but it gets a little bit unreasonable. And if we have some other stuff like multiply, okay, multiply rational 3/5, and I mean it becomes difficult to read, right? It becomes difficult to read. So to eliminate this, to make this look as natural as integer addition and other stuff, I can say stuff like in C++, I can say stuff like add R1 with R3, then add another one R4, multiply it with a new rational 3/5. Okay, so this looks much more natural, much more readable, and we wish that we had same kind of operators defined for our classes. And C++ says that, well, Java cannot do it, but I can do it. I will let you overload your operators for your classes as you wish. If you like to use them, then you can use them. Okay, then you can use them. That's what we are going to do. So the basic mechanism for operator overloading is again overloading. Remember, we overloaded functions. Now we are going to overload operators. And operator overloading, the rules are simple. This is what the rules are actually. When the compiler sees something like this, doesn't matter whatever it is, okay? When the compiler sees a plus b, I don't know the types of a or b, it thinks, okay, it says that to evaluate this, either I am going to call this function operator plus a comma b, if there is such a function, okay, either this one or, okay, or it's going to call, well, operator plus in this case is going to be a global function, right? So let me do this then. C, okay, so either it's going to say C gets the value of operator plus AB. So if there is a function named operator plus, and it takes two parameters and it returns something I assign to C, or it's going to call this one. C gets the value of A is an object of a class. In that class, I have this operator plus function as a member function. I give it a parameter B, send an argument B to it, and get the result and assign it to C. Okay, so to overload operators, you are going to either okay, you are going to either overload this function as a global function. Well, in C++, we don't like global functions much, but well, it is possible. Or you are going to overload this operator plus as a member function of this class, whatever the class of this A is. Okay, so that's the basic idea of operator overloading. Any questions? Okay, so let's do some examples then. Okay, let's go to our class rational. Okay, let's go to our class rational. Let me write the header file then. Okay, if not defined rational age, then define rational age. Okay, and class rational. Don't forget the semicolon. And in my private integer nominator and integer denominator. Okay, let's assign initial values of 1 and 1 in case something funny happens, and public, okay, and rational, um, integer nominator, initial the default value is 1, integer denominator it is integer is 1. And let's, well, I am not going to go into implementation stuff here. I am going to implement only the ones that are okay. So why don't I take this to our trusty, not so trusty ChatGPT and ask it to, okay, complete this class definition with setters and getters. Okay. So setters and getters are there. That thing is there, and we don't care about the, okay, we don't care about the simplification, reducing, etc. I am going to put it in there. Okay, so that's the basic class of rational. It has the constructor, it has the getters and setters, the constants are there, etc., etc. So it removes this. It removed this, but it removed this initialization stuff. So it is writing classic C++ code. Okay. So what did I say? I said that using this, it should be possible to write this kind of stuff: plus operator, multiplication operator, and etc. and etc. Why don't we write add first, so that we know what's happening before, and then we are going to do it later. Okay. Let me rename this. Rename this to, how do I rename it? Rename this to rational main.cpp, and this is resist rational dot h. Okay, good. So let's write that function. For example, add function. Add will take what? It should take people over there. You should talk to. How many people are there? I have what? 15 people? That's it? Okay. So, Mehmet Akif, do you want to say something? What does this add take? Are they talking? No, nobody's talking. Okay, what does that add take as a parameter? Object of the rational class, but you should take it as a
Sir, you muted yourself. We can't hear you.
okay, so they can talk. How about now?
Yeah, we
Okay.
can hear.
Okay, good. It looks like you are in the projector. It sounds like you are in the projector. Okay. Do you feel like you are speaking from the... Okay, never mind. Okay, so rational is going to return a const. Okay. It's a const function. It's going to return a rational. And how does this work? How does this work? I am going to do this then. Do you guys remember how the addition works for two things? A over B plus C over D. Int denominator is going to be my numerator times others denominator, right? Is that correct? Yeah. How does I can't write it in code. I had to do this. I can't write this in the code. Okay, so A over B plus CD. Okay, so A times D plus C times B over what? B times D, is that correct? Is this correct? Okay, let's implement it then. My numerator, others denominator, plus others numerator, my denominator, over this one. Okay. Where is it? Okay. So my numerator, others denominator, plus my denominator times others numerator. This is my new denominator. And my new numerator is just, this is my new numerator. And this is my new denominator. It is my denominator times others denominator. And just return a new rational numerator and denominator. Should I be worried about the numerator becoming 0? Should I be worried about this number becoming 0? Can this number become a 0? No, why? Because, I mean, if this number is 0, either this one is 0 or this one is 0. This should never happen again, right? This should never happen because I make sure that whatever object I construct, okay, whatever I object I construct, if the numerator is 0, then it's going to be 1, right? So it can never happen. Even if it happens, okay, rational constructor will take care of it. So this is how add works. Let's write the multiply. Okay, let's write the multiply. Okay, the other one, my numerator is going to be my numerator times other's numerator, and multiplication is always easy. And denominator is going to be my denominator other times. Okay, that's it. So these are how multiplication, why don't I write the complete name, just two more letters. These are how the add and multiplication works. Okay, how they work. Okay, so that means what? That means now this one works. This one will definitely work. When I compile it, R1 will add R3 to it, and it will return a new rational. And I'm going to run this, call this add function again on that new rational, and then it will return something, and I'm going to multiply it with this rational. So this line works. This is fine. Let's make this work now. Okay. And again, as I said, it is simple. What did I say? I said that when the compiler sees this one, it's going to call either this one or that one. So let's overload this one first. Okay. Let's overload this one first, operator plus, as a function member. So this is how it works actually. So what I do is I just take this add, copy it, I just paste it, change this name to operator plus. Believe it or not, it's that simple. Okay. I am just overloading the meaning of this plus operator with a new function. Okay. Now that add is going to work. And if I like to do the same thing with multiply, I will do this and change it to operator multiplication. That's it. Now this line will work too, because R1 plus R3, compiler is going to call this one R1 dot operator plus R3, and it will return a rational here. It will return a rational. Then I will do with this with R4. It will return another rational, etc. But the thing is here is this, okay? We know that in the usual classical behavior of the plus and multiplication, the precedence of the plus is less than the precedence of the multiplication. This one will be done first. Okay? This one will be done first because multiplication has a higher priority than the plus operator. And the fact that you are overloading the operator doesn't change this precedence rules, and the multiplication will be done first. In this case, line 6, this add will be done first. Then this second add is going to be done. Then finally, this multiplication will be done. If you like to do the exact same thing, then you need to parenthesize it. Okay. Now the upper part and the lower part are the same exactly. Line 6 and line 8 produces the exact same thing. Okay, any questions? So this is the whole story about the basics of the operator overloading. Okay, the whole story about the basics of the operator overloading. Okay, good. Let me move on then. Why don't we try the other one, the one that says that, well, it works this way too. Let's write some global functions which we don't like, but to show that with the global functions, I can do the same thing. I can do the same thing, and I can achieve operator overloading with the global functions. As I said before, we don't like global functions in C++, in object-oriented programming languages. But, well, I mean, well, we are C, right? Every time we say that we don't like global functions, but we write a global function, which is main anyways, okay? From time to time, unfortunately, we have to write global functions. So let's write this global function. Rational operator, okay, operator, let's write the division operator, okay? Okay, tell me how many parameters does the operator division take? What? Two. Somebody says in the class 2, okay? So it's going to be two parameters. One is the left side of the division operator. The other one is the right side of the division operator, okay? So const rational, don't forget the reference sign, okay? So my R1, okay? And const rational R2. Should I write const here? Const here?
No.
Okay, somebody from the projection device said no. Okay. Yeah, of course I cannot write it, okay? But this is meaningless. What does this const signify? I mean, is this function const function? No, I mean, for the globals doesn't make sense. So don't write const here, but always think about const. So how does the division operator for the rationals work? Okay, I just would say rational, okay, return rational R1 dot get numerator divided R2 dot get numerator, right? I divide them, then do the same thing with R1 dot get denominator over R2 dot get denominator. Okay, so that's the rational division operator implemented as a global function. Okay, global function. Of course, I could have done this. I could have done this as a member function too, but just to show you how it is done as a global function, I did this. We prefer member functions because this is object-oriented programming, right? We prefer member functions because this is object-oriented programming, but you are going to see that for some cases, really, doing the operator overloading as a global function makes things very efficient, makes things a lot less messier, and etc. We are going to see what we mean later. Okay, good. What else? Am I missing anything? And we have the multiplication, but maybe the minus operator. But we can always write the minus operator. Okay, let me show you a trick here, okay? Let's write this operator. Let's write this operator, okay? Wouldn't it be nice to have, why don't I do this? Why am I talking about this? R3, R1, R2, okay, R3, this is R1, R2. By the way, these two lines compiled, okay? Okay, this R3, when you type it, when you see this one, R3, R1, dot operator plus R2. Both of these lines are okay. Okay. Okay. And okay. Okay. So both of them are okay. Both of them are compilable and they work. As you see, my editor, see, it said that operator plus is a keyword. Operator plus is a keyword, right? It said that. Okay. So it works. So I am going to do this. Wouldn't it be nice to, okay? Wouldn't it, by the way, no. Let's make this one. We defined this one plus, we did not define this one. Okay. So let me make this and it works. Okay. So I like to do this. R4 gets the value of minus R2. Okay. So I'm going to do this. I'm not going to do R1 minus R2. I am going to say minus R2. Okay. So it is a little bit different than, implementing this operator that takes two parameters, right? This one takes two parameters. This one takes a single parameter. So let's implement this as a member function. Okay, rational operator minus. How many parameters am I going to take? How many parameters am I going to take? Remember, when the compiler sees this one, it's going to say R4 gets the value of R2 dot operator minus, okay, R4 gets the value of R2 dot operator minus 1. What am I going to write here? What am I going to write here? Operator minus parentheses. What, R4? R2? What am I going to write here?
Just R4.
R4 here? Really? R4 is already here. Doesn't make any sense. I mean, why am I sending R4 to the minus operator? What am I going to write? Here I write, remember this one? Here I write R2, right? R1 is already has the half the data, okay? And R2 brings the other part of the plus operator. I add R1 with R2, okay? So I have all the data I need to complete this addition operator. But this one is a just negation operator. It's not like subtraction operator. It's a negation operator. So, what? Minus 1. So it's going to take an integer? No. Anybody from? Say it again, projection device. Say it again.
Is it empty?
What does it say?
Empty.
It says empty.
Yes.
I think he's saying that it should not take any parameters. Okay? Because what does this function return? I mean, what should it return? It should return another rational, which is exactly the same as R2 with a negation sign at the beginning. So it's going to return a new rational with a negative of this R2. So I have all the data with R2, and I am going to return I'm going to return an irrational with a negative sign in front. Okay, so that's what I'm going to do. Okay, so that's how I'm going to implement it. This will not take any parameters. And should it be a const function or not?
Not const.
Yes, it is. It's a const function, right? It should be a const function. Who is that guy talking? Kais, are you talking?
Yes.
Oh, okay. So it should be a const, and why? Because I'm not going to modify anything, okay? And tell me what should I write here? Return rational. Return rational. What should be my numerator? Numerator. My numerator will be exactly the same as my objects numerator. Numerator exactly the same as this one, but this is exactly the same. But maybe I should do this. So I send minus. Okay, so minus this integer, comma the numerator, and that will be my uh, minus operator. But this minus operator is a unary minus. Okay, it's a unary minus. Okay, unary minus operator. This unary minus operator, okay, of course, doesn't take any parameter as a class member because it has all the data needed. Remember the benefits of using object-oriented programming, okay? Most of the time, you don't have to pass as many parameters as the other languages like C, okay? Because most of the data you need is already in your hands. Okay, so that's the unary minus operator. That's how it works. Tell me another unary operator that works for the rational class. How many unary operators are there? Well, minus is one of them, right? What do you think? Plus is another one. Plus is we can write stuff like this, right? It is okay to write. It is okay to write things like if I have two integers, integer I and j, his initial values are, I don't know, this is 0, j is 1. I can say stuff like minus j, right? This is fine. But you can say, even though it doesn't make much sense to write it, but I can say this too, okay? Plus j. Because, I mean, this one will change the sign of this integer. This one will not do anything. Plus is there too. So it doesn't make much sense to overload this plus operator. But if you like it to compatible with all the integers because it works for the integers, let's implement this operator, or we can choose some other unary operators. Okay, let's ask ChatGPT to give us list all the unary C++ operators. Unary plus, unary minus. Oh, plus plus. We forget about the plus plus, right? Yeah. Okay, and logical not, bitwise not, size of the reference. Does that make any sense? Okay, these are all good. Okay, plus plus makes a lot of sense. Let's implement plus plus maybe. But what is the meaning of plus plus for a rational? How about this not? What is the meaning of not for a rational? What is the meaning? Really, is there a meaning of not for a rational number? I mean, not 3/4, 2/4. Let's see what it says. Boolean expressions. Possible implementation for rational class. If you are come on, just stop. And whether a rational number is 0, you can okay, so maybe, okay, so that's what it means, okay, well, it says that I'm going to give you a suggestion. Maybe if you are trying to see if it's a 0 or not, and that's what it says. So let's implement one of the unary operators for this rational class. By the way, let me do this. Efendim hocam. Aleykümselam. Şükür hocam, bir yaramazlık yok. Hocam acil değilse dersteyim, sonra arayabilir miyim? Tamam oldu hocam. Teşekkürler. Güle. Okay. Let me ask you this. Can I change this name to F1? Multiply, instead of multiply, I just write F1. Can I do this? Of course, why not? Because multiply is just a name, right? Can I do this then? Can I change this to minus? So whenever somebody sees a minus b, it's going to call this function. In fact, it's going to do a addition operation whenever it sees a minus. Okay? Can I do this? Of course, why not? If you can change this multiply to this multiply to F1, why not? You can do whatever you want with your function name. So it's just a function name. Okay? So I can do that. Doesn't make any sense. Okay? Doesn't make any sense to do it, but you can do it. How about this one? Instead of writing these two lines, how about doing this? Cout hello world. Okay. I am writing hello world on my terminal, whatever the terminal is, and I am then returning 1 over 1. Can I do this? Of course it is. It's my function, right? I do whatever I want. My point is, the compiler doesn't know what you are doing and what you should do with the operator overloading, okay? Compiler thinks that you are just writing another function, and it is a specialized name, but doesn't matter what name it is. It's just a name, okay? So some people get confused that I can do whatever I want with my overloaded operators, okay? Of course, you should do meaningful stuff with your operators, especially with plus, minus, multiplication. But sometimes, let me fix this, but sometimes I have to make this decision. Remember, we had a little bit difficulty in deciding whether we should overload the exclamation mark, the not operator. And I ask you, what should be the not? And you did not, as always, as happens, you didn't answer anything, including Kais. Okay. So I asked ChatGPT. ChatGPT says that I don't know what exclamation mark for a rational is. Maybe you may ask whether this rational is a 0 or not. Okay. If it is 0, then it's going to return true. Otherwise, it's going to return a false. Okay. So something like that. Or maybe you say, when you say exclamation mark, maybe I can switch the numerator with the denominator, the opposite, right? Maybe I can do that. I don't know what it is, okay? Sometimes you need to give a meaning to it, okay? And it depends on you, and you don't have to overload the operator for your class if it doesn't help, okay? If it doesn't help. For example, we don't know how to overload the dereference operator for the rational class. Dereference operator doesn't make sense. Remember what we do with the string, with the integers, if I have integers 1 and J2, okay, I can say stuff like minus J, right? I can do that. And yeah, in C, it is possible to say J, not J. Okay. In C, it is possible. In C++, possible, we don't like it. But how about this? Did they implement this for integers? No, doesn't make sense. I mean, J is not a pointer. Why are you taking the reference of it? They did not overload the unary star operator for the integers. So we don't like it. Okay, for C++. We don't like it. We kind of say it is okay, this one. This is definitely okay, right? Okay, this is definitely okay. My whole point is overloaded operators are your functions. You can implement them as you wish, as you like. But at the end, they should be helpful to you. Okay, they should not be confusing. Okay, they should not be confusing. We can always overload the unary star operator for the rational class, but you should think about it. I mean, am I helping or am I hurting? Okay, most of the time, if you think about it, am I helping or hurting? You will see that you will understand you should implement it or not. Okay, so unary minus was a lot helpful. Okay, because I can do the unary minus stuff, and in fact, let me implement while I am at it. Let me implement the binary minus operator too. So I like to make it R1 minus R2 again. How many parameters should I take? The binary minus operator. Binary minus operator. So the binary minus operator should take what? It should take, like the binary plus operator, it should take a single rational other. Is that const or not? Of course, const, like the other one. Okay. Am I going to think about this again? Multiply this with this one, minus multiply this with this one, etc. Or this is what I am going to do. Return what? Return. Oh, you don't know this one. How am I going to do that? Okay, let me do this one. Rational, my numerator and denominator plus minus other. How about this one? I am calling the unary minus operator implementation. I make a new rational from myself. This is a little bit inefficiency, but for now, yeah, we are going to use this one because you don't know some details about how to make it more efficient. Okay, so this binary minus is going to work nicely, right? Yeah. Okay, good. Yeah.
Either C's minus operator. I'll understand which one to use.
It's a very good question. Did the projector hear the question? How does the compiler know that which one to call, this one or this one? If it is calling this one, then I'm in trouble, right? It's a recursive function called infinite recursion. Well, your question is same as this one. Your question is same as this one. When the compiler sees this one, which one will it call? The negation operator or the subtraction operator? Of course, negation. Why? Because there is only a single parameter here, right? I am passing this argument, just one. So it counts the number of parameters you are passing, arguments you are passing, and that's how it knows. Remember the definition of operator overloading or the function overloading? Well, as long as you give a new signature, you can use the same name. Here we are using the same name. Names are same, exactly the same. This is operator minus and operator minus. Both of them are exactly the same, but one of them doesn't take any parameters. The other one takes a single parameter. So it is overloaded, right? Their signatures are different. So that's how it knows. That's how it knows. Good. Any questions? Okay. Projection device. Do you have any questions? $16 of you are in there. Okay, that's amazing. Okay, so let's continue. Let's think about this. Do you really think we should implement the plus plus operator? I mean, what is the meaning of plus plus for a rational? Increment the value of rational by 1 over 1, huh? Or increment the numerator by 1. Which one? So it's kind of vague, right? I mean, how does the your customer, your class customer, know the meaning of plus plus operator when you implement it? Okay, so they should carefully read your documentation saying that. Okay, they should definitely read your documentation saying that the meaning of plus plus for rational class is this. Okay, so you should be very careful about it. So we are at a very gray position right here. I mean, we don't know. We made a decision that let's not implement the exclamation mark for the rational class because it doesn't make much sense. Difficult to interpret it. If we like, we can implement it. We can give a meaning. For the plus plus, we are not that sure. I mean, we are not that sure that we should implement it, and we are not that sure that, I mean, if we implement it, what should be the meaning, okay? Well, in these kind of cases, my suggestion is don't overload it, okay? Operator overloading is there to help you to eliminate this kind of mess, okay? This is difficult to read. This is much nicer to read. But if I start putting stuff like here, plus plus R1, what is the meaning of plus plus R1? I don't know, right? I don't know. Okay, so well, it looks like I'm going to overload this plus plus operator for the rational class for the sake of showing you how to overload a plus plus operator or minus minus operator. Okay, but maybe in real life for the rational class, maybe I should not overload it. Okay, good. If there are no questions, I'm going to take some break. After the break, we will come back and we will continue with our operator overloading on the rational class. Okay, 15 minutes. Let's be here around 9:40. 9:40.
Hello. Hello. Bu Fatih Usta'nın yazısı Hocam ben şunu tamamlayayım. Hangisini söyleyeyim? Hocam plus operatörünün bir tek parametreli
Evet.
yazdı. Bir de iki tane parametreli yazdı ya.
Yok lan para... Ha, aynen. Evet.
Tek parametre mesela şu işlem üzerinden gidelim abi. Tek parametreli olduğu zaman bu R2'nin bir fonksiyonu mu oluyor? Yani nasıl desem? Şunu uyarladığın zaman kanka.
Onunla uyarlanmaz ki ama.
R1
Aynen bu olmaz ki. Şununla
da
gider
gider.
karşılaştırmaya çalışıyor. Aynen. Aslında şu oldu. Bununla bunu toplama ayrı bu şey. Evet. Ama senin dediğin artı o tabii ki. Artı R2 oldu.
Ben toplamadan bahsediyorum.
Toplamada ikili koydu mu? Bilgisayarı açacağım şimdi. Toplamada var, resim çektin mi? Ben geç geldim de oğlum, bazı operatörler görmedim. Aklımda. Lan bizim sesimiz geliyormuş lan şeye. Nabil ya. Evet, Nabil şey anlatıyor. Abi. Hep böyle. Biliyor musun? Parametreleri yazdım mı böyle? Tamam. Ed oluyor zaten. Mesela Ed'e de tek yazmış. Ha, onda şey yapıyor o zaman. R2 dot operator artı parantez içinde R. Öyle algılayıp karşıya atıyor. Eşitlik oluyor.
Böyle nasıl yapıyorlar?
Bunu yapardın ama bunun karşıda olması lazım gibi bir şey.
Mesela şöyle bir şey olsun. A1 eşittir A4 eksi A2 eksi da bunun Unary bir bayramında olur mesela. Öyle söyleyeyim.
Ha, onu şey ben GPT'ye sordum.
Binary değil mi?
Hocam hani bir parametresi var dediniz ya.
Bunun bir parametresi yok ki. Şundan bir tane R
Sayın
temporary çıkıyor. O da binary işte.
Hocam bu ilk başladığında neyin subtraction fonksiyonu var? Şu R1'in mi?
Hangisi?
Hangi objenin
kendi içinde
ilk
soldan
görecek mi?
Şimdi bunun expression tree'si var, tamam mı? Expression tree'si şu. Şu. Hangisi yapacak burada? Şu değil mi? Ben şurada operatör R4 R3. Tamam mı? Bundan çıkacak şeyi
artı.
şuraya bir tane R2 yapıyorsun. Bundan çıkacağı da assignment operatörüyle
Hocam bu şu an neyin hangi objenin fonksiyonu kullanmış olduk burada?
Şu mu?
Yok hayır. Hangi objenin artısı oluyor?
hangisi global yaptıysan eğer global minus
Tabii global'dır o zaman.
global minus yaptıysan eğer operatör minus R4 bölü R3. Eğer sınıfın parçası yaptıysan R4 nokta operatör minus R3.
Peki bu toplamayı falan böyle iki parametre yapabilir miyiz? Mesela şunu şuraya yaptık mı? Yok, bir parametre yaptık. Yani bir
Şey
tane.
add yaptık hocam şunun için. Şey yaptık. Tek artı operatörle
Böyle
R2
yaparız. Ya ben orada veremedim buradan buraya çevirdim.
nasıl?
İkisini beraber yaparsan ama ben compile eder ki ben hangisini çağıracağımı bilmiyorum. İkisini beraber.
Hocam bize de gösterir misiniz?
Hayır.
Gelseydi.
Nereden duydun onları ya?
Açıkmış hocam benim arkadaş ya.
Ben arkasından konuştuğumuzu sanıyorum. That's the privilege of coming to class and catching me during the break. Okay. The question was this. So the question was, R2 gets the value of R3 minus R4 minus R5. Okay. So to evaluate this kind of stuff, the compiler builds an expression tree. Okay. Expression tree is like this. Expression tree is like this. Okay. What is the order of evaluation? This minus will be done first, right? So minus, I am building a tree here. Okay. R3, R4. And then whatever I get from this minus, I am going to pass it to another minus operator, and this one is R5. And whatever comes out of this minus will be fed to this assignment operator, and this is R2. Okay? Or no, I did it wrong. I should switch it to this case. Okay, just a minute. Because the order is important for the minus, right? So it's going to be minus R5, and whatever is coming out of this one will be fed to R2. So these are my operators. These are my operator assignment, operator minus, and operator minus. To do this minus operator here with the R5, I need the result from this R3, R4, right? To do this assignment, I need to complete all of my minus operators, otherwise it doesn't work. The question was, how does the compiler know that this is a global operator or a function member operator? Well, it says either I am going to call operator minus R3, R4 or R3 dot operator minus R4, okay? Whichever is available, it will call it, okay? If both of them are available, then operator cannot do anything. It will say that I am confused. I don't know which one to call. Both of them are available, okay? So you are going to make this, okay? You are going to make it only a global operator or a member operator, okay? Both of them are not okay. If you say that I am going to implement it both ways, then compiler will give you an error message. It will say that when you call them, okay? It will say that I don't know which one to call. That's what it's going to say. Okay? Whoever asked that question, did you get well, you didn't ask me anything, okay? That was the question, and that's how I answered it.
Okay, thank you.
Okay, so let's continue. Remember what we said about the increment operators. Let's overload the increment operators. Okay, let's overload the increment operators. So this is what I am going to do. I like to do this. Again, R4 or maybe, yeah. I like to do this plus R4 or R4 plus or R2 gets the value of plus R1. Okay. And maybe from the same token, maybe why don't I do this? R3 gets the value of R1 plus. Okay, let's implement this one. Okay, let's implement this one. By the way, let me check my slides if I am skipping anything. Okay. Oh, we didn't do the comparison operators. Maybe we should do the comparison is a nice thing, right? Which one is greater than the other one, etc. We are going to do. Well, all the comparison operators are binary operators, right? Okay. Binary operators, unary operators. Okay. We did that. So I am missing the comparison operators. I will come back to that one. Const functions, etc. Our function application, maybe I should show that. Okay. This one, we'll talk about it. Friend functions. So I am skipping way over. Yeah. Well, maybe I should not talk about the plus operator for this early. I am speaking too much. But since I talked about it, okay, since I talked about it, I will overload it. I will overload the plus operator. Okay, anyways. Okay, so let's look at this one. When the compiler sees this one, what would it think in terms of this one, right? It's going to say operator plus plus, right? So if it's a member operator, member function, it's going to be R4 dot operator plus plus. How many parameters does it take? 0, right? Because it's a unary operator, right? Okay, how about this one? R4 dot operator plus plus. How many parameters does it take? How many parameters does it take? Same thing, right? You see unary, it is 0 parameters. So that's what I'm asking. Okay, what's the difference then? I mean, plus plus R4 is different than R4 plus plus, right? Maybe for this case, it is not that different, but it is different here, right? So the meaning of this one is assign R2 the incremented value of R1. Okay, increment R1 anyways. Increment R1 anyways, but assign the incremented value of R1 to R2. This one says increment R1 anyways, but assign the original value of R1 to R3, right? So it should be different. I mean, in this case, if I am calling the same function here, whatever they are returned will be assigned to R2, R3, and it doesn't make any difference. So that's the trick the compiler uses. Compiler says that whenever I see this one, I will call this function, or it will call operator plus plus R4. Okay, it will call that one or this one. Whenever I see this one, I am going to call R4 dot operator plus plus an integer, just a dummy integer, so that their signatures are different. That's what the operator says, or operator plus plus R4 1. Okay, what does that one? One doesn't mean anything. I mean, the value of 1 or 0 or some integer doesn't matter. The compiler tries to make a difference. Compiler say that whenever I see this, what did the compiler say? Okay, when the compiler sees this one, it say that I am going to call either, okay, this one or this one, right? Whichever is available is making a function call. Okay, this one says that whenever I see such a thing, I will call either this one or that one. But whenever I see this, I will call this one or this one. So their signatures, as you see, the signatures of these two things are very different. So if you overload a plus plus operator with an integer parameter, okay, that means it is post increment. If you overload operator with no parameter, that means it is pre-increment. Okay, what is the meaning of pre-increment? Increment R4 and return the incremented value. Let's implement it that way. Okay, so let's implement this plus plus operator. It's going to return a rational, okay, an operator plus plus, and it will not take anything. Is the const function or non-const function? Is it const? Really? What does this do? It will return something, but it modifies R4 too, right? So it is non-const, right? It's a non-const. Okay. It's this is a const function because it doesn't modify R2. But this one is going to modify this parameter, right? So it's a non-const function. And let me do this. So what is the meaning of plus plus? Add one to it, just one integer, 1.6. Okay. So how am I gonna return? Okay. So first of all, add one to myself. How am I going to do that? How am I going to add one to myself? So yeah, maybe I do that. Maybe I can call one of these stuff, right? So maybe I can add
Denominator
one.
to numerator.
So Hijran, say it again.
Add the denominator to numerator, maybe.
And that's it. Add numerator to denominator, and that will be it. Right? Is that correct? Yeah, maybe I would do that. Okay. So set numerator to get numerator plus get denominator. Is that correct? Set numerator to, yeah. I am adding my denominator to the numerator, and this will be my new numerator. Is that correct? Is there any possibility to make a division by 0 out of it? No, it cannot be happened because I am not setting the denominator, right? So that's the plus plus. Okay. So I need to return myself. How am I going to do that? Okay, okay, I'm going to return this one. Return a new rational. Okay. Get numerator and get denominator. I would have said dn, but I didn't do that. Okay. So this is the plus plus operator. So I am incrementing myself and I am returning a new rational which is equal to myself. What? Well, a copy of myself. That's a better way of saying it. Yes, that's true. I am not returning myself as a reference. I am returning a copy of myself. Okay. What? Can we can I can return myself as myself without copying, but we don't know how to do that yet. Okay. Which one is preferable? Well, this way, I think this one is preferable. The book says this. Somewhere in the book, it says, should we return a const object or non-const object? Okay. Okay, this is okay, right? And a rational plus another rational and call output on it, or call, for example, a getter on it. What is I can say this. Okay, let me go to the main function again. I can say add one rational to another rational and get numerator. Okay, I can do this and I can print it out. Okay, this is possible, right? And it looks nice too, right? No problem. But how about this one? How about this one? R1 plus R2 whatever it returns, set numerator to -5. Is it okay? Yeah, whatever R1 and R2 return, R1 plus R2 returns a rational. Whatever that rational, whatever returned as a rational, I am changing the numerator of that rational to -5. Is this okay? Yeah, syntactically it is okay. It compiles. But should I be able to do this? Okay. should I be able to do this? What is the meaning of it? I mean, this number is a temporary rational, right? Whatever I have returned from plus function is a temporary rational. Okay. That temporary number is going to go away. It will be killed. But before it gets killed, its numerator will be printed out. That's fine. But this one says that whatever it returns, it will be killed. But before it will be killed, I am setting its numerator to -5. Doesn't hurt anything, but it is not meaningful, right? It just doesn't mean it is nonsense. So should I prevent this from happening? The book says that yes, do that. Okay. Put a const at the top of it, at the beginning of it. So I am returning a const for you, and you cannot modify that const. Why? Because for the const rationals, set nominator doesn't work because it's not a const function, right? So it says that return a const from this plus operator or the multiply operator or the add operator so that the customer cannot do such a thing. Okay, that's what it says. But C++11 says that in order for the move semantics to work, you should not return const objects because I am going to optimize them later. Maybe I will do some optimization. Maybe I will reuse those temporary objects to make things more efficient. Okay, so it is up to you to make this decision. Returning a const is nicer way of returning stuff. Returning non-const makes it possible to have more efficient move semantics code, and we'll talk about the move semantics later. Okay, later during the semester. Okay, so don't take whatever the book says as it is. The book says definitely const. I am not saying that as definitely const because with the C++11 and 17, things are a little bit different. Okay, so we overloaded this plus operator, but this is okay prefix operator. Prefix operator plus. Let's do the postfix. Okay, how do I distinguish postfix from prefix? Of course, I am going to do this. Rational plus and postfix. Okay, postfix operator, of course, is going to take a integer I, and I'm going to completely ignore this integer. It's not a meaningful integer. Compiler just passes some number so that its signature is different from this one to this one. Okay, just to make the signature different. Otherwise, they would have exactly the same signature. Then I cannot overload them, right? I cannot overload them. So how am I going to do this? Well, I am going to return the unincremented myself, but I'm going to increment myself. So why don't I do this? Increment myself. But let me make a backup of myself first. Okay. Rational myself. Okay. And rational myself is going to be this. Get my numerator and denominator. Okay. And increment myself by 1. And then return what? Return all myself. Maybe myself is not my initial copy, and return my initial copy. Better name, right? So I take a copy of myself, I incremented myself, and I return my initial copy. This is the postfix plus plus operator. Good. Any questions?
Okay.
Yes.
I think these will not work properly with negative values, right?
This will not work for what?
Negative values, like for denominator and numerator.
For negative values?
Yes.
Why not? Aren't you doing the same thing? For the plus operator, so what I am doing is A over B plus 1 over 1, right? That's what I am doing. So it is going to be A times 1 plus 1 times B over B times 1. It is B. Doesn't matter A or B are negative. It's going to work, right? Are you there?
Yes.
Okay. So maybe you are right in terms of what? No, I think it's going to work, right? Because this A could be negative, B could be negative, right? Doesn't matter which one. If both of them are negative, then it will work because it is A over B again. If A is negative, yeah, it will work. I think it should work. I don't think that we should keep the negative sign as a separate sign. I think what you are thinking about is that. Anyways, I am not that much concerned about the soundness of the relational class in terms of mathematics. I am more concerned about the object-oriented and the C++ programming rules. Okay, it may not. I mean, you may find it. You may find it not working for some cases. We can test them out later. Yeah. Yes. Of course, compiler says that. Compiler says that. Well, I have seen this. Okay. I have seen this. Whenever I see this, I am going to call this one. Okay. But whenever I see this, I will call this one. Remember what we said about that? The compiler says, whenever I see this, I will call this one, right? So the compiler makes that decision. If the plus plus is in front of the object, it will call the operator plus plus with no parameters. But for this one, it will call it with a single parameter, which is an integer.
How it knows.
Compiler knows that, okay? Compiler is built that way. The guy who coded the compiler, designed it, said that whenever you see something like that, okay, whenever you see something like that, okay, call this function if it is available. If it is not, then call this one, whatever is available, okay? That's how the compiler is implemented. And whenever you see this, call this one. Whenever you see this, call this one. Whenever you see this, call this one. Okay? So that's how the compiler is implemented. Those are the rules.
Can I ask something?
Sure.
We write plus plus R4, for example, but we use copy. Does it cause any confusion?
You mean in the implementation?
Yes.
What kind of confusion do you think are there between these two?
We work with their copy values, but actually we want to change their actual value maybe.
Yeah. Well, here I am changing my numerator, right? Both of them modifies this object. whatever that object is. Both of them sets the numerator to a new value. Okay? Both of them modifies the object. Both of them increments the object. But the first one returns the incremented rational. The second one returns the initial copy of the rational. Whatever is returned, okay, is copy of something. Whatever is returned is copy of something. But the first one is a copy of the modified object. The second one is a copy of the initial object. Understand?
No.
Then ask it again. Maybe I did not understand your question. Well, I understand your question as you are telling me that I am not modifying the current object, right? I am playing with the copies. I am saying that,
Yes.
no, I am not playing with the copy. What does this do? It sets my numerator, right? So set numerator is in both of them. Both of them modifies the object. When you say R1 plus plus R1, it sets the numerator. Or R1 plus plus, it says the numerator, okay? Both of them modifies the current object. But this one, the first one returns the modified object. The second one returns the initial one. That is the copy of it.
Okay. Are there any make sense call by reference? What does it meaning? If we use call by reference, what would it happen?
Well, it doesn't take any parameters here, right? I mean, there is nothing to talk about call by reference here. Maybe you mean this. Why don't we? Okay, maybe this will make it clearer. Okay, let's do it this way. Let's overload the minus operators for prefix and operator, for prefix and postfix. Okay, but let's do this time in a global function. Okay, let's do that. Okay, so I am going to do this. Okay, R1 minus R1 and R1 minus, both of them. Okay, let's overload them as global operators. Okay, both of them. Okay, so rational operator minus. So again, this is not a class function, this is a global function. How many parameters does it going to take? How many?
One.
Just one, right? Why? Because previously it used to be 0 here, right? This one. This used to be 0 because I have all I need, okay? But this time I need to pass it. So it is going to be a const rational and my rational, whatever this R is. Okay. And then I am going to do the exact same thing here. I will set the numerator of this R dot set numerator. Well, this time I am going to decrement it by this much, right? Then I will return what? Return just R itself, right? Return R, because that one is already decremented. That's as simple as this. Okay, but I made a mistake in this function knowingly, but nobody is telling me anything. What? Oh, yeah. That one I didn't realize that. Yeah, it should be R dot get numerator and R dot, yeah. Okay, there is another one. This one wasn't intentional. This one was, I didn't know that. Okay.
The const one?
Say it again.
The const? Will not
You
be
are
there.
saying that the rational cannot be const. Why? Because it's going to be modified, right? Okay. Who said that? Who is
Mohammed.
talking? Mohammed. How come I don't see your name here? Anyways, okay. So Mohammed is saying yeah, he's right. He said that this cannot be a const. If it's a const, then set numerator is not going to work. Okay. Set numerator is a non-const function. So I modified it. So Hijran, does this answer your question?
Yes. Thank you.
So, well, maybe you were wondering, I mean, if this one looks like it's going to modify something, but I don't know what is being modified. Well, the modified thing is already my object, and that's why this is not a const function, right? This is not a const function. Okay,
I
let's,
missed it global function,
okay,
but I
so
understand.
okay, good. Let's do this. Let's do this. Operator minus minus. This time I am going to do it for the post decrement. So this is what we are going to do. You are going to say integer I. Okay, something to, usually you say ignore. Okay. So I'm going to do that. So R dot set numerator is going to be that. Yes, that's true. I'm going to decrement it, but at the beginning, I am going to do rational backup is copy of R and return backup. As you see, the pre-decrement operator is more efficient than post-decrement operator. Why? Because post-decrement operator has to take the backup of this object, right? This one doesn't have to take it. That's why we prefer minus minus R minus minus I over I plus plus, because minus minus is more efficient. Well, compilers make it efficient anyways, but that's how it works. Okay. Good. Any questions on these? So we keep talking about the same thing over and over again. Okay. It will be this. Whenever the compiler sees such a thing, okay, it will either evaluate this one or that one. That's the rule of the operator overloading. Okay. So we keep adding those kind of functions to our class as global functions. And from time to time, we look at the details. For example, there was this detail of the difference between the pre-increment and post-increment operators, right? That was a little bit different detail. Also, the detail of should I return a const or non-const? The book says always return a const because modifying that temporary object is not helpful for anybody. So use the principle of least privilege. Okay, return a const. But C++11 says that C++11 says that no, don't do that. Let's ask this to ChatGPT. Okay. Okay. So let me do this. Okay. Let me do this and go to ChatGPT. Ask, should I return a const rational from these functions? What would be the benefits and downsides of returning const objects? Where did it go? Okay, here it is. So it says benefits of returning const prevents unintended modifications like that. Okay. Okay. Encourages good coding practices. Okay. Returning const objects. Okay. But don't modify them. Like this is the temporary. Okay. Copy construction limitations. Non-const methods. Okay. Function is generally best to return non-const rational unless you have specific reasons. Return non-const values because they are expected to return a modifier. Okay. What? Marking the return value as const can limit the performance without significant benefits from a temporary object. So it says that the compiler might find a better way of, maybe I didn't ask the question right, because usually I would continue and do some other stuff. Maybe let me copy, for example, this one. Yeah. Okay. Without the operator overloading, or maybe with the operator overloading. This plus operator. Okay, go to the chat GPT, modify this one instead of this code here, type this one and send it. Unintended modifications, etc., etc. Proper usage, consistent API design, limited flexibility, inhibits, yeah, this one. So if I ask the question the right way, so inhibits smooth semantics and potentially redundant in C++. Okay. You may not gain much from returning const object. Usually expect the operator to return modified results. So it has downsides and it has upsides. And usually the modern approach is don't return const. Just people know what you are doing and return non-const so that compiler can figure out maybe reusing this rational for more efficient implementation, for more efficient code. Okay, good. Any other questions? Okay, let me continue a little. Do you have another class here? Really? I don't think so. There is no class. People are waiting outside. Let me check what they are doing here. Because, I mean, 10:30.
There's no lesson after this.
There is no class, right? Okay, these are the people from the other. Okay, so let me tell you this, and after that maybe we can stop. It would be very nice to write this one, right? Okay, so I like to print this out, or maybe I can do this. So maybe I can say R1 plus R2 is, and then or better this way. Okay. R1 plus R2 equals, then what? Then do this. R1 plus R2. Okay. This is nice, right? So this one is printing R1 to the screen. This one is printing a plus. This one is printing an R2, then equal sign, then add these two together and do it. Okay. So we are going to overload this one. Okay, stream insertion operator. That's the stream insertion operator, right? So let's think a little bit about it. What does the compiler? Let's look at the simple case first. Cout R1. The compiler will say that I am going to do this. Cout dot operator stream insertion R1, right? Can we overload this operator stream insertion that way? Can we overload it? The answer is no. Why not? Can we overload it? And I said no. And asking you again, why can't I overload cout dot operator stream insertion? What is the type of cout? I know the type of R1, right? Here. I know the type of R1. It is a rational, right? If I add this function in rational class and get this parameter, then I will be fine, right? Burada ders mi var arkadaşlar? Çıkın gidin o zaman. So that's what I did, right? But what is the type of cout? Cout has a class, right? I don't know what that class is. Even if I know what that class is, I cannot modify that class. That class doesn't belong to me, right? That class doesn't belong to me. So what am I gonna do? Well, that gives me only one possibility. I need to overload. Then I need to overload this one. Then operator stream insertion. Whatever the type of the cout is, okay. I don't know how do I know the type of cout? How can I get the type of cout? You look at the definition of cout from the header files, IOStream, right? Or smarter way. What is the smart way of getting the type of cout?
And use auto.
Auto, not auto, but it is just the brother of auto. It is not auto, but what? Auto deduces a declaration, right? I am not going to declare anything. What? Remember this one? Declaration type. Declaration type. How do you type it? DCL. The declaration type. Declaration type, like this one. Declaration type of cout, whatever it is, right? And I will take it as a reference. I will take it as a reference. So it is going to be my out object, and the right side is going to be my rational, right? And it's going to be it's going to be that one. So it's going to be rational. Okay, I am going to overload this one. Let's go there and let's overload this global function. Well, I mean, the circumstances don't give me any possibility of overloading a class member function, because I don't know the class of the cout, and even if I know it, okay, it is easy to figure that out. Even if I know it, I cannot go in that class and add a new function. That's not my class. I don't get to modify any class that I have. I may not have the source code. Even if I have it, that's not a good practice to modify somebody else's class, right? So I am going to do this, okay? So whatever the declaration type of cout is, my first parameter is going to be that one, okay? And my second parameter is going to be my rational. Question, should rational be a constant or not? If I'm printing something out, if I am doing this, cout R1, is this going to be constant or not? It's a constant, right?
Constant.
Yeah, it's a constant. Let me put this constant here. How about the other one? How about the other one? Should this be a constant or not?
Yes.
But I mean, if it is constant, if I am not modifying the cout, if I am not modifying, you are saying that I am not modifying R1 just to print it out, right? But if you are not modifying cout, how does the cout knows where it left on the screen, right? Cout has to remember something. I mean, cout says that I printed this character at the second line of the screen. Now I am at the third line, etc. Right? It should know what is as printed. So you are modifying cout actually. Okay. So I am modifying cout. That's why this first parameter should not be const. It should be a reference, and it is modified, and it is not a const. Okay. Good. Okay. Good. Question again. What should this function return? What does it return here? Whatever it returns, I just ignore it, right? In this case, I don't care. Like, I don't care what it returns here, right? But it is important here, whatever it returns. So it becomes important here what it returns, because I am going to use that in a new stream insertion operator. So what should it return then?
cout.
Yeah, so what is the type of cout? So it should return the cout itself so that I am running this and then again and then again. So it should return whatever the declaration type of, okay, declaration type of cout object. It should return that one. Okay. Well, usually we don't type it this way. I am going to sneak it out for you, and I am going to say that the type of cout is all stream, output stream. Okay. I am going to return an output stream object, and I will take an output stream object. Okay. And I will return a reference so that I don't keep copying the same thing over and over again. So this operator stream insertion is a global function. Unfortunately, it has to be implemented as a global function. Otherwise, I cannot get into the class OStream and add this new overload of stream insertion. So this has to be a global function, and this global function, okay, takes this OStream object as a reference and takes this rational, constant rational as a reference object, okay, and it does whatever it does, and it does whatever it does, and it returns the whatever it takes in. Okay, let's implement it. Let's implement it. Okay, so how do you print a rational? Okay, then maybe I should do this. Whatever it passed to me out is passed to me, right? Print the r dot get numerator get numerator first, then print a division sign, and then r dot get denominator. And that will be at no end of lines. So I print it myself, okay? I know how to print it. Okay, this one is an integer print. This O stream knows how to print integers, okay? So this one is an integer print. This will return the out again. This one is a string print, and this one is another integer print. At the end, I will return my out as a reference. Okay, so let me do this that way, and let me put it that. Okay, good. Okay, so here is at least one case where you need to overload your operator as a global function, because the other way is not possible. The other way, as a member, I cannot add this one as a member to the all-stream class. Good. Any questions? Okay, no questions. So as you see, the basic idea of operator overloading is simple, but there are lots of details to keep in mind. For example, this how to overload the stream insertion operator, how to overload the plus plus minus minus operators, and etc. and etc. That kind of stuff, or whether they should return a const or not. Okay, Java says that the language Java. Okay, well, this is too messy. So my solution is no operator overloading. Java doesn't allow your classes to define the plus minus operators, overload those kind of stuff. And if you like to overload something, just overload the add function or the divide function or multiply function. Okay, so don't overload the operators in Java. Java doesn't do that. Okay, so it doesn't complicate any stuff. Okay, there are many operators that we are going to overload. Some of them are overloadable. Some of the operators are not overloadable. There are many operators to overload. Let me show you. Yeah. Okay. These are some of the rules. The first one is, maybe it is self-explanatory, maybe. When overloading an operator, at least one parameter of the resulting overload operator must be of class type. Would this be a nice operator overload? Integer. How about this one? Integer operator plus plus int I int j. Do you see what I am overloading? A global operator overload. It takes two. Sorry. I messed it up. Do you see what I'm overloading? Operator plus. I am overloading the regular integer addition, right? No, it says that, no, you can't do that, okay? You can't do that. If you are overloading an operator, one of the resulting operator must be of class type parameters. So class type means it cannot be a fundamental type such as characters and doubles and etc. So one of the parameters has to be a new class type. So you can't do that, okay? You can't overload this kind of stuff. Okay? So you are not going to change the meaning of integer addition, double subtraction, etc. Okay? So most operators can be overloaded as a member of a class or a non-member global functions. These operators can be overloaded as a class members only. Operator assignment, index operator, arrow operator, and the function call operator. Function call operator is a special one. It can take as many parameters as you like. Okay? Another rule. You cannot make up new operators. Whatever is available, you only overload them. This is not operator creation. This is operator overloading. That operator has already a meaning and you are overloading it. You cannot make any if. For example, you can say that, well, I like this. For example, I don't know what. Yeah, I like this one a lot, the dollar sign. Okay. And I am going to make this $1 operator. No, you can't do that because dollar is not an operator in C++. You cannot make new operators. You only overload them. Okay. Okay. And then you cannot change the number of arguments that the operator takes. Okay. For example, you know that this works, right? You know that this works, modulo operator. Modulo is a binary operator. When you say I guess the value of 2 modulo 4, it gives you a value. How about this one? Why don't I do this? Wouldn't that be a nice thing? No, because modulo is not a unary operator. It's a binary operator. You cannot change the number of parameters that an operator takes, or you cannot change the presence of it. However you define plus and multiplication, plus will be done always before multiplication. Okay, these are some of the rules. Okay, you cannot change the presence of the operators. You cannot change the parameters numbers of the operators. The dot operator, remember A dot F1, cannot be overloaded. Okay, binary scope resolution operator, size of operator, ternary condition operator, and the dot star operator, which will never cover. Okay, cannot be overloaded. Okay, cannot be overloaded. And as expected, this is a funny one, but it's a rule, right? You cannot have default arguments for the operators. This would be funny to have an operator like this, right? For example, can I do this? Like this one, rational 1, 1. Okay, this is a binary minus. If the parameter is not provided, use the default argument of this one. Well, can you imagine how it's used? It is like R1 minus something, but something is missing, so it is R1 minus. Doesn't work that way, so this is bad. Okay, no default arguments for the overloaded operators. Maybe I will talk about this slide later, but I think for now, I will. This one is nice. I think for now I will stop, and on Wednesday morning, as you expect, I will ask you 1 or 2 questions about operator overloading. Okay. I think I will say this. Write this class and overload this operators. Or maybe I will do this. No. I will give you a driver code for a class, and I will ask you to implement that class. Okay. Good. Okay, that's it for today. Any questions from the projection device? Or any questions from the online audience, which is 17 people? Okay, I guess no questions. Let me stop it. Stop recording. And I can print out the